All right, let's get started. So welcome to the Bridging Your Student Skill Gaps live webinar. A couple of housekeeping items. You can ask questions and address any questions throughout the whole webinar and in the Q&A box at the bottom of the webinar. You can also follow us and tweet us at mendix.com. And if you have any great thoughts or feedback, feel free to use the hashtag Mendix University. Our speakers for today will be Professor Michael Litman. Welcome, Professor.
Thanks. Glad to be here.
So Professor Lippmann is passionate about computer programming education, and he's an expert in virtual reality at Concordia University, Wisconsin. And my name is Daniela Field, and I'm the Faculty Technology Advisor here at Mendix, and I've taught lowcode development at my alma mater at MIT. So for those of you who might not be fully familiar with Mendix, our company was born to help enterprises win with apps. We are the fastest and easiest low-code platform to create web, mobile, and enterprise solutions at scale. Our goal is to unleash business and IT collaboration and create applications 10 times faster. In addition to that, just to give you an idea of our customers, we've built a lot of innovative applications using Internet of Things, AI. We build applications for rabbit experimentation, new products and channels. In addition, we've also helped companies engage better with their customers, improve their operational efficiency and workflows, in addition to also legacy migrations and apps. So this is just a list of some of our customers to give you an idea of our broad customer base. In addition to that, we have also partnered up with SAP and IBM, where they have recognized us as the low-code solution. So today, this webinar is part of our university program, where we have over 100 professors in 5 or more countries delivering the platform and low-code solutions. We have an open curriculum, in addition to also faculty professional development, and over 4,000 students who are getting Mendix certified. And we are recognized by leading institutions as well, MIT, Harvard, WPI, and so on. So in our agenda today is to talk a little bit about Professor Lippmann's observations through his teaching experiences, talk a little bit about what skills gap computer science students need, and why low-code bridges those gaps, and how Mendix specifically has helped them. So Professor Lippmann, can you tell me a little bit about your observation in the current curriculum?
Yeah, so I've been teaching computer science at the college level for over 18 years now, and I think teaching programming has changed over those times. My background specifically is teaching computer programming, so I teach most of the programming classes throughout our curriculum. And I think our students that come in, they have kind of 2 challenges. One challenge is they've been human beings for 18 years of their life. And something I say in class is that human beings are such good problem solvers that they have trouble articulating how to solve problems. I always joke around kind of the first day of class, how many of you got to class today without bumping into any walls? And, you get the couple of people that raise their hands just, being smart Alex, but in general, we don't even think about it. In fact, we're paying attention to our phone with our head down while we're dodging, bobbing, and weaving around people. So as humans, we're just so good at solving problems that we really have trouble breaking things down to those small steps. So one challenge we have with new students coming into college trying to learn computer programming is that they need to overcome and either retrain their brain to think like we need to tell a computer what to do in those little tiny baby steps. Now, the other side of the equation is we're also throwing this programming language at them that, even if you've been a programmer for years and years and years, I kind of teach this idea that, programming is the skill set. The language itself doesn't matter. So if you're already a proficient programmer and there's a new language that just came out, in a weekend you can pretty much get up to speed in that language just learning how to declare variables, ask questions through conditionals, and write some loops, and you could already solve a huge classification of problems. But now what we're doing is day one to these students who've never seen programming potentially before, we're throwing this very foreign language at them, whether it's Python or Java or whatever, and it's an immediate intimidation factor. So we're asking them to jump 2 hurdles day one. Change the way they solve problems, so we're trying to undo 18 years of practice, and then, oh, by the way, also be scared of this new syntax.
Yeah, it can be very intimidating to just learn something completely new. In addition to that, as you mentioned, breaking things down into simple step-by-steps. So from your experience, what would you say are the key skills that students need to actually be ready for the industry?
Well, so you can kind of work backwards and, think about your average app you download on your smartphone or you download for your computer or whatever, and really try to consider what are the different components that go into making something like that. So, obviously you have your business logic, your programming logic type stuff, which I think we do a fairly good job in the modern computer science education teaching. Well, but then you have to think about databases and UI and security, and then also integrating with third-party APIs to bring data into your applications. And not just from the theoretical side. You have to really think about this from the applied side of things. So students need to be able to conceive of writing a program themselves that persistently stores data, whether it's on-site or off-site on some database, has at least relatively usable user interface, takes security into consideration at least at some level, and whether you're pulling in real-time stock quote data or sports scores or whatever it is, this idea of having these data sources that live out there in the world and being able, kind of having this standard that we have today with RESTful APIs and JSON and pulling those things into your applications. And our students today just, they don't have that whole applied connection. They're getting the programming logic pretty well, but, by the time they're late in their program, they really have some deficiencies on really knowing where databases and things like that fit in their world. They get a lot of those things in theory. So, we have a theoretical class on databases where they're learning about, normalization and foreign keys and all sorts of stuff like that. And maybe they have a human-computer interaction class where they're learning about the theory of user interfaces, and they have a security class, same thing. But we don't do such a great job today of bringing all those pieces together in one cohesive unit where the students really understand the place of each of those components in the software applications that they're writing, even when they're graduating as seniors.
So the focus is primarily on programming logic and not as much, and on the rest it's less hands-on. So what are the benefits of introducing your students into using low-code for the classroom environment?
Well, I think there's a couple of benefits. I think over the last 10 years, every year I'm kind of trying to identify the next, lower hurdle that we can throw in front of our students. And we've used some tools like Game Salad and stuff like that have served a purpose, but these programs are kind of toys. So one thing I've been impressed with Mendix is it's not a toy. This is an enterprise type thing that you really could be a professional developer and only ever use Mendix as your tool. I mean, that's completely legitimate. But if I'm going to just think more broadly than that, like I just said a few minutes ago, that our students that are coming out as even seniors, I would say, do not have an adequate understanding, or they haven't been adequately exposed to the world of integrating all those little pieces into a fully functional software application. Or if they do get it, they're getting it in that very last capstone course where we have them do this big project, and then they're just kind of trial by fire forced to do this stuff. Where with a tool like Mendix, they're able to see how all those things kind of fit together in the first 2 weeks of their freshman class. Now, they might not understand all the theory under the hood, but they at least understand from an applied perspective where databases fit, where security fits, where user interfaces fit, how do I connect my user interface to my programming logic. All these pieces that we historically have either historically have done a fairly poor job of intermixing throughout our 4-year curriculum, let's say, they're now seeing in the first couple of weeks or first month of the class at a pretty advanced level, so that we can, we now have a reasonable foundation to build those theory classes off of, because now we can assume our students understand where they fit in the world of computer science.
So speaking of your students, can you tell me a little bit more about how you actually integrated the low-code platform? You mentioned a little bit that your freshman students, just within the first couple of weeks, are already exposed to that. Can you tell me more a little bit about those classes?
Sure. So I've really integrated it into 3 of my classes. And 2 of them are kind of the same class. So our freshman introduction class, let's call that Programming 1, as well as our graduate introduction class. So we have 2 different graduate programs here at Concordia, and we have a graduate program in computer science, and then we have a graduate program in information technology. Now, the computer science program, we're presuming those students are coming in with some programming background, so we don't have an intro course in that program. But the way I like to kind of describe it is that computer science and information technology are different sides of the same coin, where information technology spends about 25% of its time creating new stuff, probably through programming or something like that, and 75% of their time using things that have already been created and getting these guys connected together to solve some problem, where computer science is about 75% creating new stuff and 25% taking things that have already been created and bringing them together. So with that in mind, we do have a intro programming course in our Master's in Information Technology program, just so we have a baseline of we know how much software development these students have had available to them from their different schools. So we kind of teach that first class in that graduate program the same way, but in a faster pace as we do in our freshman Programming 1 class. So in both of those classes, I had them run through, I kind of split it across 4 or 5 assignments in the freshman class across the first couple of weeks. In the graduate course, it was the first week because that's an accelerated type course in a shorter format. But they worked through one of Mendix's rapid application development tutorials that takes them from I've never seen Mendix before to, hey, I can create an entire application in Mendix. And it's probably, between 8 and 12 hours of material. They watch a video and follow along using the Mendix tools and things like that. So I had them work through that initially to kind of take almost a crash course in Mendix. So in that first couple of weeks, they have that familiarity with what you can do with programming. Because otherwise, I think students come into these classes with this mindset that it's like, oh, I'm going to write video games my first semester or something like that, and then they're upset when you're asking them to reverse strings and do sorting algorithms and stuff like that. It's not as cool. But in that first couple of weeks, if we can kind of show them why we're learning these little fundamentals and how it fits into the bigger world, I think that can be very, very beneficial. And then what I do the rest of that semester then is I teach our theoretical concepts in class. At this point, we're using a language called Python. And then I show them, I usually introduce the topic showing them in Mendix, and then we write the equivalent code in Python. So we get that theoretical side of things, but then we get the applied piece in Mendix so they see where it fits in the world. So that's what I'm doing in those intro courses, and I do that throughout the semester. I just go back and forth between the applied and the theoretical. Now, in that senior capstone project, this is in our undergraduate program. So as seniors, their very last semester here, they have a giant project that they have to log their hours. It's 300 hours worth of work, and they're creating some large software application project. So depending on whether they're a computer science major or an information technology major, they either have to have 75% or 25% of their project being creation. Well, so what I had, one of our students, actually 2 different students are using the Mendix platform, but one of them I think is a pretty cool example. One of our seniors is a information technology major, and I would say historically this is not the strongest programmer, but she's bright. And so one issue we've had in the past is when these students get up and give their 45-minute presentation in front of a giant audience to kind of finally, earn their stripes and graduate, the IT majors tend to not show that well. Their projects don't look as complete because their creation piece is not very impressive. So I had this student go through that same tutorial program to kind of learn Mendix because she didn't have the advantage of being introduced to it 4 years ago. And what she did is in probably 3 weeks, she put together an application that was far greater than she would have been capable of doing on her own. So what she built with Mendix is it's kind of an attendance tracking tool where, in Mendix you can create classes, you can add students to those classes, so the faculty member kind of has a way of managing who's in their class and things like that, as well as taking a picture and uploading that picture to Amazon S3. So we're connecting with a third-party API. We have a user interface and all this other stuff. And then we're using machine learning to identify when a student comes into class, we take a picture of them to take their attendance. When they show up to class, we take a picture, and it uses Amazon's recognition API to determine whether this student is in the class and gives them credit for being in class today. So this is a pretty cool project that they put together, probably 90% with Mendix, and then the other pieces are just using these third-party APIs and getting them to talk together.
Wow. I feel like that's a really, really cool app, but also at the same time so scary. I wouldn't want my professor to know if I'm in class or not. No, that's really impressive, that just within 3 weeks they were able to actually build the user interface, security, and also do a third-party integration. That's pretty exciting. And also it's pretty interesting to see that also on your introduction class, the students are able to pick up the platform, which actually brings me to my next question. Can you talk a little bit more about how you enabled the students to learn the technology and what was available for you and the students?
Yeah, so like I said, I probably leveraged Mendix's early tutorials. Well, not even early tutorials. There's quite a bit of quite a few video tutorials on Mendix's site. And the one I use, I think it's called the Rapid Application Development Track. I might be misrepresenting that slightly, but I think that's what it's called. And it really takes you through, let's call it a crash course in using Mendix as a professional tool, and it even ends with having the students can take a test to get a certification in Mendix, which I think looks pretty good on their resume and stuff like that. Also gives them the satisfaction of how well did I learn this stuff over those last 2 weeks of all those homework assignments that I was going through these tutorials. But I really leveraged Mendix's existing tools to kind of teach, almost like teach my students for me, because I was kind of going through those tutorials at the same time. It was something I kind of decided, well, let's go ahead and try it this semester. And, teachers, any teachers who are on the call kind of know that sometimes you just have to stay 5 minutes ahead of your students, even though that's not your intention. So I kind of let Mendix teach them, and I was going through it at the same time, kind of expecting I would learn it at a little bit quicker pace. And it was actually kind of interesting because several of the students, I think, became more of an expert in it than maybe I did, because they maybe kind of took their time and explored it a little bit more instead of just getting the nuts and bolts of it. But in any case, I really leveraged Mendix's existing tools. So it was pretty easy for me to integrate this into my classes without any additional time for me. In fact, I perceive it's going to save me time in the future, because there's always these examples where you're trying to show some real-world example of something and come up with an applied example before you show some theoretical thing in class. And if you can kind of actually build it in Mendix, which is a tool they're already going to be familiar with, so this is kind of thinking ahead 2, 3, 4 years in my classes, I think that could be kind of a beneficial thing I keep coming back to over and over and over again in my classes.
Yeah, so the students were pretty much self-enabled and watching the videos and online tutorials. And you actually did say correctly, it's the Rapid Developer Path, where the students, as you mentioned already, can get certified and actually industry recognized. I also want to highlight here, Professor, that while we do have the online training as well, we also have classroom training, and we'll be coming up at University of Alabama and in Quinnipiac in the middle of May to actually do more training and self-enablement for professors. And of course, we help professors with a dedicated faculty advisor, which is someone like me. But your experience overall was pretty good.
Oh, I would say better than pretty good. I think as a faculty member, we get hit with all sorts of, things to try in our classes, and, emails that, tend to go directly into trash, or they're sending us random textbooks and things like that. So it's really hard to separate the wheat from the chaff sometimes. But I don't know, there's something about this. And maybe it's because I'm always looking for this kind of tool. And around that same time period, kind of, early January, let's say, right before my intro course starts at the end of January, that's kind of when I'm scrambling to see if I can find some tool that, what's going to be my, I never really called it a low-code solution, but what's going to be my applied product that I can use to introduce programming concepts to the students, to try to avoid the syntax for as long as I can. What's that tool going to be this year? And, some of them have been kind of fun to mess with, but I think I referenced it earlier. I always kind of refer to them as toys. This isn't necessarily, these aren't products that my students are going to come back to and use as juniors, because they kind of outlive their usefulness pretty quickly. They're almost geared towards, maybe elementary and junior high kids who are just trying to get a taste of game programming or something. So I was already in the mood for looking for a new tool anyways, and I think Mendix kind of, I say fell in my lap. So I looked into it like, oh, well, this doesn't really feel like a toy. I think the very first time I had a conversation with the folks over at Mendix, I think the first thing I was enamored with was the fact that it can connect to a third-party API. I mean, I almost forgot about the database and security stuff or whatever. Just the fact that my students very early on can, bring in stock quotes or sports scores or something like that into their applications without really knowing anything about networking or RESTful APIs or JSON or any of this stuff. They didn't really have to know that stuff. They could just plug the stuff in and it works. I mean, that's exciting for early students, and that's something that none of these other toy tools could do. I mean, it wasn't even something that crossed my mind that they might be able to do.
Yep, it's definitely an enterprise-grade product. So I think with that, I would love to open it up for questions from our audience. We'll give people a couple of minutes to ask questions. There's a little Q&A box, so feel free to ask any questions to Professor Lippmann or I. So one question that actually comes up pretty often, and I hear it here is, since it's an enterprise tool, how much does it actually cost? So it's all free. Our university program, we're very committed to making the professors and the students successful and enabling them as quickly as possible. So there's no cost associated with downloading the product or installing it or deploying it or giving the students the hands-on needs that they must have.
Just like my classes, we get poor audience participation.
Oh. We have one more question here. He's curious about what kind of examples you present that go back and forth between Python and Mendix.
Okay, well, so, Mendix has this thing called data flows, which effectively, and I think I probably leveraged them quite a bit because in that, in that intro course, I'm really focusing on, even though in our early discussion today I said, here's the 5 things that students coming out as seniors really need to know with all the database integration and things like that. And those are things that I think we can really focus on through their 4 years. But in that intro course, I primarily am focusing on the business logic, the programming logic type stuff. So we're doing things like reversing strings or creating, you put in some amount of money, maybe you owe $9.31, you give the guy a 20, what's the most efficient way of giving them change, stuff like that where they're practicing tools like that. So I have them build a little program in Mendix that has the text field for entering in the amount of money that they're giving them, how much is owed, and then they hit a button, and then that would call call the code in Mendix that, they're not writing actual code. These are kind of drag and drop type of logic pieces, and they're called microflows. And the thing is that I'd have them write that logic in Mendix to do the change. For how much change is coming back in the most efficient way. And then I'd have them go over and write the exact same logic in Python where they're getting kind of the traditional, almost C-like syntax for writing code, and they can see the similarities between what you do in the microflows versus what you do in the in traditional syntax. So they're seeing both sides of the coins, and they're seeing those commonalities. Because one thing I teach in my classes is that, all programming languages, well, I kind of start off by teaching this idea that, how do human beings solve problems? I say, well, we remember stuff, we ask questions, and we use a lot of repetition. And then I say, well, all programming languages have facilities for these 3 things. So usually they're, emulating memory through variables. They're emulating asking questions through conditionals or switches. And they're emulating repetition through loops and functions and recursion, that kind of stuff. So this then gives me a platform for me to show that Mendix does those same things. Mendix has the facility to remember pieces of information. It has the facility to ask questions, the facility to do loops and call other microflows and things like that, just like you would do the same thing in Python. So they're seeing 2 separate tools accomplishing the same task. One of them looks pretty, the other one is pretty boring because you're just running it out at the console, but they're seeing the same thing being solved twice.
And how do so in addition to that question, how do the students do with that transition? Do they find it challenging, easy? Like, what's their experience?
I think they find doing it for the Mendix side fairly easy. I mean, obviously, as you give them harder and harder examples to solve, then it becomes more challenging. But, I think after they've gone through the kind of the Mendix crash course, they're comfortable enough to start writing simple programming logic in Mendix because they've seen enough small examples of that. I think it also makes it less intimidating for them to jump into the Python side of things because they're able to focus more on what's the correct syntax to write here. Oh, I need to indent this. I capitalize something when I shouldn't have capitalized. So they're able to focus more on that the syntax pickiness as opposed to the business logic because they've already been exposed to the business logic. I mean, in computer science, one of the things we teach before you can solve a problem, you have to understand the problem. All right, then you have to write the algorithm for it, the recipe, which is an unambiguous set of instructions for solving a problem. Well, they've effectively done that by solving it on Mendix. So they've written out a little recipe for doing it. They've implemented it using Mendix, using the microflows. Then when they go over to Python, now they're converting that recipe, which has already been converted into a microflow. Now they're converting it into the equivalent Python syntax. And I think doing those steps forces them to break the problem down into smaller pieces anyways, but it also makes the Python side of things, or whatever, let's say high-level language you choose, significantly easier to learn because they're seeing direct comparisons between, I'm going to call it the equivalent. So even though Mendix is more visual and drag and drop and things like that, where they're not typing in syntax, you see those equivalent things on both sides. You see where you're remembering stuff, where you're asking questions, where you're doing repetition, and I think that makes the Python side of things more easily digestible.
Thank you, Professor. So we have another question. Do you find your students are primarily writing data systems, information systems, or knowledge-based systems?
That question, the answer to that question probably changes depending on which class they're in. If we're talking about their first class, they're writing very, simple little, almost things to practice their algorithms. So I think Mendix allows them to look better than they are at that point. So I don't know in Python whether they're writing any sort of larger system that you could even call a real solution to anything. But a lot of times what they can do is we'll have them build something bigger in Mendix because you don't really have to, you don't have to understand the underlying theory of the database or the security or anything like that, or how the user interface actually works. You can just do it in Mendix, and it makes them a little bit more excited about the tool, and maybe gives them some motivation moving forward that, oh, well, in a year or two, I might be able to do this with whatever high-level language I'm working with, but for now, I can do this today using Mendix. Now, if we start looking at some of our, our more advanced classes that we're also looking to start incorporating Mendix into, well, at that point, now we can start using Mendix to help teach some of the theory things, the database theory and things like that. So that's where we probably would be shifting more into creating different kinds of solutions with Mendix rather than just using it to mimic basic programming logic. So I feel pretty strongly that the tool will scale throughout our curriculum for those different classes, and the teachers can leverage it to kind of focus on the piece that we're looking at. I mean, I guess I could use an example like in a database class. My colleague, Dr. Wall, teaches this class, and he's quite talented with databases, but a lot of times those classes can be, certainly from his perspective, could feel kind of dry because you got these deer in the headlights looks out there because you're teaching the theoretical side of databases, and the students don't necessarily know where these things fit in the world. But if you can side by side start giving them a use for a data set, so maybe they create a little application in there when the course isn't really focused on programming, now it's focused on they're creating a system that's leveraging this data. They can get some data in there, they can create a system that uses some data, maybe it's generating reports or whatever, things like that. And then he can talk about why that database was modeled that way from the theory side of things. So that focus becomes less on, programming logic, creating some sort of weird algorithm that solves something interesting, and now it's more on, giving people access to the data in interesting ways, and how Mendix's data modeler actually makes that applied process, it gives you the applied process of the theoretical stuff they're teaching in class. And then just kind of take that from different courses that you're aware of in computer science and decide, okay, well, how can it match up with some of the different theoretical concepts that are in there? I don't think you can just use it for the programming courses. I think it actually would become very beneficial for the other courses, so the students are always reminded where the theoretical stuff that they're learning in class right now that they might perceive as being stupid, where those actually fit in the real world of programming, and they might start seeing those similarities like, oh, well, the video game I play, it has authentication, and it's remembering my scores from the last time 20 times I've played, things like that. They might see where it fits in their world a little bit better.
Thank you, Professor. And there's a couple of other questions. One of them is, how do we provide ongoing training to faculty? And I can answer that. So we do, Professor, you already mentioned how you were able to use the self-paced online learning tool. So that is one option that we have for professors. At their own convenience, they can go in and follow the learning path. In addition to that, we also have Boston headquarter-based training where the professors can join us with our customers and partners. And also, we're going to have professor-specific training in the Boston headquarters. And on top of that, we're also doing a university roadshow. Right now, we're traveling to the University of Alabama and Connecticut in mid-May, and we're open to other universities as well, where we'll be doing training and faculty assistance. And of course, in addition, the professors are more than welcome to email us directly and ask any questions as they're going through their curriculum. And another question here is, can you teach data science and analytic methods using Mendix? Have you done that in your curriculum, Professor? Or?
I have not, because I've only introduced it in those couple of classes, but, you know, I almost think of some of the things that those seniors have used, you know, kind of fall into the category of analytics, at least a little bit. But I guess I would say I don't have any concerns about using those types of things, certainly with the connection to the third-party APIs and bringing in data and modeling even big data type stuff. But I haven't done it specifically, but I don't see where there would be a challenge with that. And it might even make it a little bit lower bar because now you're able to visualize the data more quickly than maybe focusing on some of, you know, Python's packages for data science or big data, which, you know, even though they're not overly difficult, can be a little intimidating when you first get into them. But usually students are seeing that kind of as juniors or seniors, at least that's been my experience. So maybe they're a little bit more ready for that level of intimidation, but I still think Mendix would be a positive tool for that as well.
Yeah, so on the product itself, even though we're not like a BI tool, we do have the capability of creating dashboards, charts, analyzing any kind of data, searching through it, and things like that. And in addition to that, you can also expose your data through OData and consume it by more of a BI tool like Tableau. And there is more of another comment rather than a question. One of the professors is saying that some of the students that he's taught Mendix to have found it very, very helpful for learning Agile. That's true. Do you cover Agile development in your curriculum, Professor Lippmann?
We do in our, well, they're probably first introduced to it formally in our software engineering class, which I actually take as a sophomore. So we have not used Mendix in that class, but I think that would, I think it would certainly be a very compatible tool, because one of the things that changes, you know, when students see the name of a course being software engineering, they immediately are thinking about programming, where software engineering is almost everything other than the programming. And Mendix allows you to get that programming logic in there without spending too much time programming and spend a lot more time on the project planning aspect of things. And that's where you can start bringing in the various approaches where you have, you know, different teams working on stuff. And Mendix does have some team building tools built into it. I have not messed with them, but I remember seeing them in there when I was going through the tutorials and things like that. So maybe you can speak more to that or what the state of those things are. But I think that that's going to be something we're definitely going to be doing here in the, not in the fall, but next spring when we offer our software engineering class again. We've been talking among the faculty here in our department about other classes we can integrate Mendix into other than just kind of this initial pilot program. So I think we're pretty pretty excited about where else this can fit in our program. And then, if we look 4 years down the line, are our students coming out with, are they stronger coming out where we're ready to dump them into the real world than they historically have been?
That's exciting. Yeah, no, it's very exciting, and definitely Agile development is where the industry is going towards, especially for creating very innovative products, because you do need to be rapidly changing things and pushing products out the door. So the Agile methodology or process is very helpful for the students to learn while they're still in school, because they have an upper hand and advantage when they hit the industry. So I'll give a couple of minutes for any other questions. Meanwhile, if anyone is interested in learning more, feel free to go to mendix.com/university-program. So I'll just give a couple of minutes. Oh, I have another question. So what's the most interesting part of the platform?
I think for me, and this really starts from day one, I think my students would have a different answer. But for me, it's always been that third-party API integration. I bring a lot of my students to hackathons where we do these programming competitions all over the country, and the amount of time that we spend on some of these applications just integrating with third-party APIs. I actually have not done this yet, but I really should. And maybe the next hackathon we're going to do this, because typically what I do is when we go to these programming competitions, we get 15 or 20 computer science students, and I break them up into teams where each team has kind of a stronger programmer and then a couple of freshmen that aren't real confident, so that they can all, it's a learning experience, not necessarily, trying to win the competition type of experience. It would be very interesting to force all the groups to use Mendix at the next hackathon and see if they can see how much more they can accomplish, because usually these hackathons last 24 hours, and at the end of 24 hours you got to show what you have. And all these hackathons have these requirements of, usually it's one of their sponsors. They have 2 or 3 different sponsors for the hackathon, and each one has their own API, and you have to, like for instance, Twilio or something like that. You have to integrate it into whatever solution you're building somehow. Well, dropping in third-party APIs for people who haven't done this before can be kind of intimidating, where Mendix makes that very simple. So that's always been my kind of favorite piece just from that perspective. I would guess that students would say that having a user interface as a freshman is the more interesting piece, or having data persistence as a freshman is the more interesting piece. So maybe if I was to sum that up, kind of thinking of it as the combination of the low code, the interface, and the database. Those 3 pieces together, where you can have persistent storage plus a user interface plus some code much earlier on in your program than they historically would have. I think they appreciate that more because the projects feel more interesting to them.
No, that's great. And we have done hackathons at other universities, and also with customers themselves too. Believe it or not, grown-ups love hackathons too. So I got another question from another professor about announcing the dates of when we'll be in Alabama and at Quinnipiac University. So and also about our Boston-based training. So our Boston-based training is monthly training in May, June, July, and now it's a great time for professors to get ready and started with self-enablement. And we'll be at the University of Alabama on May 14 and 15th, and then University of Quinnipiac in Connecticut on May 16 and 17th. And Professor Lippman, I think I'll see you in Alabama, right?
I am hoping so. I got the details today, and I am running it by the warden. also known as my wife. So making sure that that is an acceptable date, but my calendar looks good for it, so I'm going to give you a 95% yes.
Okay, great. Well, I look forward to seeing you and any of the other professors on the line join us live as well. I just want to conclude by saying that thank you, Professor Lippmann, for your time. I really appreciate it. I've been really blown away by the classes that you're teaching Mendix in, and with all the development that the students have been able to do in such a short time. And if anyone else is interested in learning more about our program, they can just go to mendix.com/university-program. And I'll also follow up with people and let them know about our training dates as well. Thank you, Professor Lippmann.
Thank you.
And I want to wish everyone else a very great day. Thank you.